Okay, there we go. So, which measure of central tendency best describes each data set? What would you think we need to use for the home? Home? Should we use the mean or should we use the median?
Median.
Let's use the median. Why is that? Because is that, let's see, we said median before, but now that I'm looking at it, what do you think? I don't know, maybe the mean is better. I know that this skews the mean, but look, it skewed the median too. What do you think? These two, it looks like it doesn't really matter which one you use, whatever one's easiest for you to find. What are we using this information for, I guess, would be part of the deal. I suppose you're scouting out the other team, I don't know, figuring out who to guard and who to play. But do we want this mean or do we want this median? What would you say? What do you think more closely matches the team itself? Look at the team at the top of your page, the dot plot that you have. Does the median match it better?
Yeah.
Okay, so median matches better because of the skew. How about the visiting team? What would you say?
If you like decimals, do median. But if you like decimals, do median.
Okay, so you're just saying it depends on whether you like decimals or not. So does it really matter? Doesn't matter. They're pretty close. Whatever's easier for you. Describe the relationship that seems to exist between the data distribution and the values of the mean and median. Okay, so when it's symmetric, what do you notice about mean and median? Symmetric. Oh, spelling. Mean and median close. Am I too low or can you see that? Move it up, move it up. Okay. How about skewed? Skewed, they are farther apart. Okay. Ready to flip? Go ahead, flip the page when you're ready. Let me see what they say about this too. I want to make sure I'm not teaching you wrong. 475. We'll trust the experts. They're saying the same thing we said. The teacher's edition. When it's skewed, use the median because the mean gets messed up. When it's skewed, use the median because the mean doesn't represent thing as well. Whew. Glad I was teaching you right today. Here, flip the page. Oh, good. We needed a histogram because we're not very good at these yet. Okay. Top of the page, something to read. Jerry.
When the distribution of data is approximately symmetric, the mean is generally the more appropriate measure of standard deviation. distribution of data is skewed left or skewed right, the median is more appropriate measure center to use. The reason why the mean is more appropriate in symmetric data is due to the fact that most data points are close to the mean. There are not many of any data values that are much greater or lesser than the mean. In a skewed left or right distribution, most data values are closer to the median, with few data points being much greater or lesser than the median. Therefore, the median is not affected by these values.
Okay, so the median is not affected by skew. So if you have a median, it's in the middle of most values. It's half or lower, half or higher, and it's usually near the clump somewhere. So what they're saying is what we've been saying all along. Symmetric, use mean. And if they're skewed, use median. That was a question on the quiz that I didn't mark you off for because we hadn't talked about things enough. But when it's symmetric, use the average. The average is good. But if it's skewed, the average gets messed up by those super high or super low values. The median helps out in showing the middle ground of what we're looking at as a group of data. Okay, so let's see. Kenya, it's symmetric. What should we use? Try again. Mean. We kind of said actually you could use either. On our values, they were both about the same, but they're telling us it's more appropriate to use the mean when it's symmetric. Anna, so it's skewed. What should we use? Thank you. Ernesto, it's skewed. What should we use? 50-50 guess. Mean or median? Good job, median. Oscar, it's skewed. What should we use? Try again. And it's right up here in pink or yellow. Okay, when it's skewed, what should we use? How can we remember that? Those two sound the same. Skew, median, skew, median. What about that? Sounds like we could connect those together. I don't know. We'll just keep talking about it, I guess. Okay. All right. Histogram. We have a histogram. Is this symmetric? No. It is skewed to the left. Great. Because the skew does not talk about, the skew talks about the numbers that are not normal. It looks like normal is over here to the right. But the skew is what's off. Skew over here on the left-hand side. Okay? Predict whether the mean or median number of hours spent playing video games will be greater. Explain your reasoning. Okay? So since it's skewed, what we say would be better to use? Median. So this is skewed. Probably median will be better. Okay. Now what it's telling us is predict whether the mean or median number of hours spent playing will be greater. Okay. So who will be the bigger number? The mean or the median? Median's probably going to be a bigger number. We're saying median moves closer to the data that you have the most answers for. That the mean gets drugged down by these guys that are way over here. So these small values drag down the median or the mean or the average, but the median gets right in the middle of where you have most of your answers. So we think median will be bigger, and explain it will be closer to the data we have the most of. And that's not very great grammar there. Best grammar would probably say it's closer to the values that occur in the highest frequency. The values that occur in the highest frequency are represented here in these two tallest bins. That is the number of students playing video games a certain number of hours, and more students said they do it between 20 and 25 or between 50 and 20 than students in these other segments or intervals. Highest frequency is occurring over here in this data on the right in the high hours, and that's why median would be closer to the big values. Suppose the two measures of central tendency for the given histogram are 16.1 and 17.5. Trying to get where we can see both, or maybe it's a little bit smaller. Okay, 16.1 and 17.5. Which value is the mean and which value is the median? What did we just say about median? We think it's going to be higher, so this is median, because the median is going to be over here closer to where we have the peak. We think this one is the mean. It's smaller because of the skew. I'll raise this up higher now. Mean moved smaller because of small numbers on the left. So we have some values in our histogram far over on the left. They don't match the general trend, but that factors into our average. They drag down the average. It's like if you have a math quiz, and if I wanted to look at the average in the class, what if the majority of you got B's, but you had two students with A pluses? What do those two students with the A pluses do to the average?
They make the average go up higher.
They make the average look higher and not represent what the majority did. Okay, so when you have things skewed, it affects the average. All right, right here, instead of having things that are high, this is like you had the majority of the class had A's, but you had two F's. What do the two F's do to the class average? They lower the average. So anytime things are skewed, the average gets dragged in the direction of the skew. The median more stays in the middle, which is where the majority is. Okay? That's what we're trying to say here. Hopefully a tiny bit of that sinks in. All right, talk the talk. We're forging ahead. I know you're like, Rigetti, it's Friday. We can do this. Okay? Here we go. Top of the page, 477. Wyatt, could you read for us?
Identify which measure of central tendency would be most appropriate to describe the for each given graph. Then determine the mean and median if possible. If it is not possible, explain why not.
Okay, right here, what do we have? Is it symmetric or skewed? Symmetric. So what did we say is better to do? Symmetric. What are we supposed to use? Mean. Average is a better value when that average isn't pulled off by something skewed. So we do have symmetric, so average would be better. Looking down, we'll come back to the second part of the question. Let's look at the dot plot. Is it symmetric or skewed?
Skewed.
Skewed. So what should we use, mean or median? Median. The average gets drug up here by these high numbers, but the median is going to stay somewhere in the pack. The median by nature is going to end up in the middle of the pack, and that's usually closer to where the majority is. The majority are right here. The median's going to be somewhere down here. These numbers don't pull it as far over when we're talking about the median. Okay, which of these could we find an average? Can we find an average for this one?
There's more on the back. Exactly.
Oh, there's more.
There's a box description.
Okay, we'll look at that one in a minute because there's two things. Decide whether we should use mean or median, and then explain why we're not. Determine mean or median if possible. Can we find the mean or median in this? This histogram, can you find a mean or median? Not really. Why? What do you know? You don't have exact numbers. Can't. What do you have here?
Ranges.
We have ranges. Andy, if you were going to predict an average for this, what would you predict?
Probably predict around 4.985. So probably around 5.
You think the average is over here?
Oh, no, never mind then.
Oh wait, maybe I should be,
Sorry, I was going by the months.
yeah. Okay, so how about average for inches of rain? What's the average for inches of rain? What do you guys think?
2.9.
2.5.
2.5, somewhere right in the middle we would predict, okay? Between 2 and 3, but we don't have individual values. This could be closer to 3 than it is to 2, some of the values. We don't know for sure, but I would predict right here because it's very symmetric. Okay, but we don't have exact numbers, so we can't throw anything into our calculator. We could make predictions. Okay, now this one though, could we find a mean and median?
Yes.
How do we find median?
You can throw it in the calculator.
We could put it in our calculator, or
you could like use your fingers and cover one digit at a time.
one digit at a time. I'm going to move over from the left 5 x's. 1, 2, 3, 4, 5, 6. Actually, I'm going to move 6. 2, 4, 6. So I'm 6 x's over from the right and the left. Here's 4 more. There's 4 more. Where's the median?
3.9.
Here's the median. 3.5. How can we find a mean? Add them up and divide by how many? Let's do that. 0 plus 0 plus 4 ones. On. Clear.
And then divide by
4 plus 2 times 3 is 6 plus 1, 3 plus 2 times 4 is 8 plus 2 5s is 10. Okay, I get 85 when I add them all up. Does anybody else have them added? I make mistakes, so double check for me. Add these numbers. That's a 0 plus a 0 plus a 1 plus a 1 plus a 1 plus a 1. You can do it individually, or I kind of did it as a group. 4 times 1, 3 times 2, 2 times 4. Okay? What do you guys get when you add them all up? 85. How many x's, Jerry?
20.
20 x's. So that's what we divide by.
4.25.
So mean okay, how does that compare to our median?
The mean is higher because of the 14.
The mean got drugged this way because of that 14 and a couple of these way over here. So the mean got drugged toward the skew. These guys threw the numbers off. So mean not really in the main group. It's off to the side of the main group of values. All right? Flip the page. First of all, same question. What should we use, mean or median? And we start by saying, is this symmetric? Chris V, is this one symmetric? No. This is skewed. How do we know, how do we know it's skewed looking at a Box and Whisker plot? Jerry.
Because it's like,
Sorry, go ahead.
Because of the 126, because that long whisker on the right.
Long whisker on the right. If it was symmetric, the whiskers would be the same size. Brian, what should we use if it's skewed? Mean or median? Median. Okay. Can we tell what the median is looking at the Box and Whisker? I heard one no and one yes. Everybody look at that Box and Whisker. Can you find the median?
Yes. 11.
Where do we find the median in a Box and Whisker plot?
yes.
The line
The middle
inside the
11.
box.
The line inside the box. What does that look like to you?
11.
It looks pretty much exactly like 11. Median, and it's 11. Can we find the mean?
No.
We can find median.
We can or we can't?
We can on this one because it's the middle line. It shows up there as part of one of the 5 values that makes this plot. We can find the median. It's the middle line. Okay, I'm running out of room here, so I'm going to have to margin it. We can't find mean. Uh-oh, I told you the answer. You tell me why.
Because it's a range of numbers.
Again, it's another thing where we're looking at groups of numbers, ranges of numbers. 1/4 of the values are here, 50% of the values are there, and another quarter is there. It's a range of numbers. We don't know the exact values. All right. I think I'm going to set you loose on number 2. Construct a dot plot. Calculate mean and median. What do you think is the best representation? Remove 0. How does that affect the distribution of data? Recalculate mean and median. You've got this. Okay? Let's do this in 3 minutes. I'm setting you loose. It's only 5 numbers, so it should be easy to do what they're asking. Ready, go.